Understanding pH is essential in chemistry and biology. Logarithm is used to calculate pH. So clear concept about logarithm is very important for pH calculation. Welcome to AMIRS Math School. In this video, I will discuss about pH calculation and use of logarithm. Let's start the main topics. The pH is defined by the following equation. pH equal minus log 10 base H plus. Here, this H plus denotes the molar hydrogen ion concentration. In the pH calculation, this equation is used. Here, the base of logarithm is 10, which is called common logarithm. So we can call, in pH calculation, we use the 10 base logarithm. Now, let's see which formula of logarithm is applicable in this case. Log a base a to the power n, which is equal n times log a base a, which is equal to n times 1, that is log a base a equal to 1. When the base and this number will be equal, in that case the value of logarithm will be 1. So the value of log a base a to the power n will be just n. This is the formula which is very much applicable for calculating the pH. So we can say the base of logarithm is 10 if the value of molar hydrogen ion concentration is in scientific form. That will be easy for calculation. So let's see what is the scientific form of number. A into 10 to the power n, this representation of number is known as the scientific form or standard form of number, where this a is greater than or equal 1 to less than 10. That is, the value of a is starting from 1 to less than 10, and this n belongs to the z, that is the set of integer number. So the value of n is integer number that may be positive or negative. This form of number is also known as a standard form of number. The common logarithm of this form of number is very easy for calculation. So let's see one example of this form of number, that is 0.0000021. If we want to write this number is in scientific form, so what should we write? That is 2.1 into 10 to the power minus 6. That is 2.1. This value must be between 1 to 10, including 1. And this n, it should be integer value and which belongs to set of integer number z. So this number can be written as 2.1 into 10 to the power minus 6. This form of number is called the scientific form or standard form of number. So taking common logarithm of this form of number is very easy for calculation. How this form of number is very easy for calculation? Let's see. That is log 10 base a into 10 to the power n, which is equal to n plus log 10 base a. The value of the common logarithm of this form of number is just this n plus log 10 base a, this value. According to which formula we can write this logarithm of this value is equal to n plus log 10 base a. Let's see. That is the logarithm formula used here is log 10 base mn, which is equal to log 10 base m plus log 10 base n. This formula of logarithm is used to find this value from this value. Okay, let's see how. That is log 10 base a into 10 to the power n, which we can write log 10 base a plus log 10 base 10 to the power n. So the first value, that is log 10 base a plus this value, we can write here as a multiplication. This formula we just see earlier, that is n times log 10 base 10. So from here we can write log 10 base a plus the value of this log 10 base 10 is equal to 1. So the value will be just n. We can write this one, this is n plus log 10 base a. The logarithm of this scientific form or standard form of number is equal to n plus log 10 base a. That is the value of this exponent plus the log 10 base this value. Let's see one example of pH calculation. If the H plus is 2.1 into 10 to the power minus 12 mole, then what is the value of pH? So according to the formula, that is pH equal minus log 10 base this value, that is 2.1 into 10 to the power minus 12, this value. So here we can write minus log 10 base 2.1 plus log 10 base 10 to the power minus 12 according to the multiplication formula of logarithm. or we can write minus 12 plus log 10 base 2.1, which is equal minus 12 plus 0.32. The value of log 10 base 2.1 is just approximate to 0.32. So here, from here we get the minus 11.68, which is 11.68. So this is the value of pH. If the molar hydrogen ion concentration is 2.1 into 10 to the power minus 12, in that case the value of pH is 11.68. Now let's see the reverse process. That is, the pH equal minus log 10 base H plus. We just find that when this value of H plus is given, we just calculate the pH. So when the pH is given, in that case, how can we find the value of this H plus? What is the value of H plus concentration? In this case, we use another concept of logarithm, that is the anti-logarithm concept, or we can say the inverse logarithm concept. Let's see how. If we write this minus here, that is minus pH equal log 10 base H plus. Now, if we just convert this logarithm equation in exponential equation, in that case we can write this 10 to the power minus pH equal H plus. Or to vanish this logarithm, we have to take the anti-logarithm in the both sides, and we can write 10 to the power minus pH equal 10 to the power log 10 base H plus. So from here we can write 10 to the power minus pH, which is equal to the H plus. That is 10 to the power log 10 base H plus. The value of this term will be just H plus. So from here we can write the value of this H plus concentration is 10 to the power minus pH. When the value of this pH is given, in that case, if we substitute the value of pH here, we can easily find the value of H plus concentration. In case of this common logarithm, the exponent with base 10 is called the anti-logarithm. So if minus log 10 base H plus is the logarithm, in that case the anti-logarithm of this logarithm will be 10 to the power minus this pH. The anti-logarithm of common logarithm is the exponent with 10 base. Let's see how this anti-logarithm is work. Suppose this value of H plus, that is 1 into 10 to the power minus 1, is processed with the logarithm minus log 10 base H plus, gives the value of pH, which is 1. If we substitute the value of H plus in this logarithm, that is minus log 10 base 10 to the power minus 1, in that case we will get the value 1, which is the value of pH. Now if we want to find for which value of H plus we get this value of pH 1, that is, we want the initial value back. In this case we have to go through another process that is called anti-logarithm. The anti-logarithm of this minus log 10 base H plus, which is 10 to the power minus pH, the anti-logarithm of minus log 10 base any variable will be 10 to the power minus another variable. Minus log 10 base H plus, for this logarithm, the anti-logarithm will be 10 to the power minus pH. If we substitute the value of pH equal to 1 in this anti-logarithm, in that case we will get the initial value back. That is 1 in here, the value of pH, so 10 to the power minus 1, which is this value. So we can say if we substitute the value of 1 in this anti-logarithm process, this anti-logarithm process will give the value of H plus, that is 1 into 10 to the power minus 1. So with this anti-logarithm process, we get the initial value back. That is, this value of H plus is processed with this logarithm, we find the value of pH, and this value pH is processed with the anti-logarithm, we will get the value of H plus back. Let's see one example. What is the hydrogen ion concentration of a solution with pH 8.25? So using the equation, that is H plus equal to 10 to the power minus pH, if we just substitute the value of pH here, that is H plus equal to 10 to the power minus 8.25, which is equal 1 by 10 to the power 8.25, which is equal to, we can write 5.62 into 10 to the power minus 9 mole. Using this equation, we can easily find the value of hydrogen ion concentration. That value is 5.62 into 10 to the power 9 mole. Now let's see the correct way to write the scientific form of number, that is the standard form of number, that is A into 10 to the power n, where A is starting from 1, including 1 to less than 10, and this n is belongs to set of the integer number. So if we want to write this number is in scientific form, how we can express the number? Let's see. The first one is 0.21 into 10 to the power minus 5. Second one is 2.1 into 10 to the power minus 6. And third one is 21 into 10 to the power minus 7. That is, we can express this number in these three ways. Among these three, which form is correct? That is this one. Because 0.21, which is less than 1. So this number, that is the first number, should be starting from 1 to less than 10. So this one is invalid because this condition. The second one, you see here 2.1. So this one is between this 10 and 1. So this one is correct. And this 21, which is not correct because this one is greater than 10. So we should use less than 10 and also excluding 10. We cannot use the value starting from 10 to higher. So here all the case the value of this n is belongs to integer, no problem, but the value of this a, first case this is not valid, third case is not valid. So this one is the correct way of expressing the scientific form of number, or we can call the standard form of number. So let's see another example, that is 2130000. How can we express this number is in scientific form? This number will be 2.13 into 10 to the power 6. That is 2.13. This one is between this 1 to 10 and the value of n is 6, which is integer. So how we can write this one? That is, you see here how we get this value. That is minus 6 and in this case this plus 6. In this number the decimal point is here, and in scientific form we just put this decimal point after 2. To get this number we have to move this decimal point 6 place, that is 1, 2, 3, 4, 5, 6. That's why this one minus 6. Here you just consider there is a decimal point here. So in this case, to write this 2.13, we just move decimal point place, that is 1, 2, 3, 4, 5, 6 place. So in this case the value is 6. If decimal point is moved in the right way, in that case there will be a negative sign. If in the left way, in that case we will use the positive sign. So for the right side movement the value of n will be negative, and for the left side movement of decimal point the value of n will be positive. So this is our scientific form of number or standard form of this number.